Good day, Dr. Rafeah Wahi. I am Felicia Alice Bayi, 65976, and today I would like to present my proposal on titanium dioxide calcium alginate magnetic nanoparticles for heavy metal adsorption. So in this presentation, it is divided into 6 parts, which is introduction, literature review, methodology, expected outcome, work plan, and references. So the background of this research is the heavy metals are among the most important contaminants in the environment, especially in soil and water. The rapid growth in the industries such as metal blading facilities, fertilizers factories, mining activities, pesticides, and heavy metal wastewater are rapidly discharged into the water and indirectly to the atmosphere, and this causes a negative impact to the environment. So the problem statement of this proposal is based on the previous studies by Resilas et al. The absorption capacity of nanoparticles reported are difficult to be compared due to the changes of experimental reaction condition and the surface chemistry of the nanoparticles. Next is research objective of this proposal is to prepare titanium dioxide, calcium alginate nanoparticles. Second, to characterize the chemical and physical properties as well as the morphology of these nanoparticles. And lastly is to study the absorption of heavy metal using titanium dioxide, calcium alginate nanoparticles. Literature review is divided into 2 parts, which is magnetic nanoparticles and heavy metals. So in this slide, I have attached some structures of titanium dioxide crystals in the form of rutile, anatase, and brookite. Compared to titanium dioxide nanoparticles were a good protective materials for sunscreen because of the primary particle sizes were smaller and higher surface area, as well as it is transparent also. As for heavy metal are characterized in toxicity, which is the heavy metals are well-known environmental pollutants, and this also have the major risk to human health from heavy metal such as lead, cadmium, mercury, and arsenic toxicity. It is also regularly viewed by the international bodies such as WHO with their effects to human health. So some of the effects of the heavy metal to human health is such as they harm the nervous system and also harm cardiovascular and gastrointestinal. The next part is methodology. So methodology is divided into 3 parts, which is the synthesis of titanium dioxide, calcium alginate nanoparticles. Second is characterization of the nanoparticles, and lastly is the absorption. The first one is the synthesis of titanium dioxide, calcium alginate nanoparticles, which is taken from the previous studies by Potier et al. 2003. So first, it is consists of the decomposition at acidic pH of titanium tetrafluoride, which is the pH from 2 until 6. And then there is a growing step for the nanoparticles, which is in the oven at 60 degrees Celsius. The size and the shape of the titanium dioxide ranges from small size and spherical-like nanoparticles around 5 nanometer are not used in this work to the larger particles around 10 nanometer at pH 5 will be used at this work, and it is depending on the pH used during the growing phase. Next is the characterization of the nanoparticles, which is taken from the Resilas et al. 2011. So in this process, all nanoparticles will be characterized using various techniques, which is the electron microscopy transmission (TEM), X-ray diffraction (XRD), dynamic light scattering (DLS), and last one is zeta potential, which is Z potential. At the end of the studies, nanoparticles will be removed from the colloid by centrifugation, and pellet powder nanoparticles will be retrieved and will be dried. Next is adsorption process, which is heavy metal adsorption studies taken from Rasilas et al. 2011. So this following method conducted the adsorption kinetics and the adsorption power synthesized at room temperature at equilibrium for the nanoparticles and pH 7. So at the end of the studies, the standard colorimetric procedure will be used to calculate the lead concentration from the liquid phase. Lastly, the heavy metal adsorption isotherm experiment. So at specific initial plumbum ion concentrations at 7 pH and at room temperature, the adsorption isotherm test will be performed with lead solutions. And lastly, the nanoparticle suspension will be centrifuged for 24 hours of adsorption time to ensure the equilibrium and guarantee full adsorption. The expected outcome of this research is titanium dioxide, calcium alginate nanoparticles will be prepared. The physical and chemical properties as well as the morphology of the nanoparticles will be characterized. And lastly, the adsorption of heavy metal using titanium dioxide, calcium alginate nanoparticles will be studied. In the work plan, I have divided my work into few months, which is the duration of this research. These are the references that I use for my research writing and proposal writing. That's all from me. Thank you.